Section 2.6 is going to be on rational functions and asymptotes and how to find the asymptotes to those rational functions. So a rational function just means that it's a function that's written as a fraction, something on the top, and a variable has to be on the bottom for it to be rational. So the most basic rational function that we can have is 1 over x. So let's get our calculator out and see what that looks like, and then we can go from there about domain, range, asymptotes, how we can figure all that out, or how things change. Okay, so we see two separate little pieces. We see a little piece in the third quadrant and in the first. This one's probably needs to be a little closer to the axis here for accuracy. There we go. So I see that the pieces are just approaching the axes. So it looks like it can't ever touch the x-axis. I'm going to draw that in as a dashed line to indicate the asymptote. And same with the y-axis. It's going to approach but never actually touch the y-axis, which we can tell that one right away because x can't be 0. You can't have a bottom x 0 on the bottom of a fraction. So that vertical axis makes sense, but the horizontal you might not have expected. But it looks like we can't approach the x-axis at all, which means our vertical asymptote is x equals 0 and our horizontal asymptote is y equals 0. I tend to answer the asymptote pieces first because then I can go from that to determine what domain and range are. That it appears to be the only values that the domain and range can't be are those asymptotes. So domain is all real numbers except 0. X can't be 0. And the range is all real numbers and y can't be 0. So domain and range are always just going to be all real numbers except whatever those asymptote values are, which is kind of a nice trick to figuring out what domain and range are. Once you know the asymptotes, then you know domain and range from that. So in general, that was the most basic one of 1 over x, but in general, for a rational function where we have a function n on top and a d on bottom, there's no common factors. It can't simplify anymore. The top has a leading degree of n, so x to the nth, we'll do a x to the nth over b, x to the m, because the bottom has a leading degree of m. You know, there could be more things, but the first term is what we care about here. The vertical asymptote is when we set the bottom equal to 0, zeros of d. Set bottom equal to 0 and solve it. That one's pretty straightforward. Now for horizontal asymptotes, we care about the biggest power, which is why I wrote that in red up there. We care about the ax to the nth term and the bx to the m term. If the power on top, so n, is smaller than the power on bottom, then y equals 0 is our horizontal asymptote. That is, in fact, what happened up here. The power on top with just 1, that power is 0, and the power on bottom with x was to the first power, so since the power on top was smaller, y equals 0 ended up being our asymptote. If the powers are the same, then we care about the coefficients in front, which is why the a and the b are written there. The line y equals a divided by b would be my asymptote. And then the third situation is if the top power is greater than the bottom power, then there would be no horizontal asymptote. I'm going to add one extra thing to this list, which is going to be the zeros, which you might be asked to find at some point. The graph F has zeros at the zeros of n of x, which means we set the top equal to 0. So vertical asymptotes are setting the bottom equal to 0, and zeros are setting the top equal to 0. That will probably come up at some point. Okay, so let's find our asymptotes. Vertical, I generally do first, which is setting the bottom equal to 0 and solving for it. So I'm going to subtract the 1, divide by 3, and take the square root. So because there's a negative under the square root there, this is going to be an imaginary answer, and I'm not going to write down imaginary vertical asymptotes. So vertical asymptotes, or VA, I'm going to say none. And then horizontal asymptotes, I'm going to compare the power of the top to the power of the bottom. Since the top is a first power with just x, and the bottom is a second power with a degree of 2, then we know that this is going to be y equals 0. When the power on top is less than the power on bottom, our horizontal asymptote is y equals 0. And that's again from the chart on the first page on the bottom. Okay, letter B, set the bottom equal to 0 for the vertical asymptote. Move the 1 over and take the square root, which gives us plus or minus 1. So there are actually 2 vertical asymptotes in this case, which can happen. And then horizontal asymptotes, we compare the power of the top to the power of the bottom. Since those two powers are the same with a degree of 2, then we divide the coefficients. Top coefficient is 2, the bottom coefficient is 1, so our horizontal asymptote is 2. All right, so let's do this one. Find horizontal and vertical asymptotes of this rational graph. So the first thing you always want to do if you see that there are multiple terms being added like this is to see if it can factor first. These both look like they're factorable expressions, and we want to make sure that it's fully simplified before we solve for the asymptotes. So the top factors to x plus 2, x minus 1, and the bottom factors to x minus 3, x plus 2. One of those factors cancels. So now we are fully simplified. X minus 1 over x minus 3, and I can solve for the vertical and horizontal asymptotes. Vertical asymptote would be 3, because that's what you get when you set the bottom equal to 0, and the horizontal asymptote, when you're comparing the power of the top versus the power of the bottom, since they're both x's, that means that the powers are the same, and the horizontal asymptote would be the coefficients, which is just 1 divided by 1. Now, we do have to pay attention to those factors that we canceled. So obviously they did not end up being asymptotes, but if you look at, they are included in the original. So negative 2, which is what we would get looking at this factor here, you can't have negative 2 in your domain because it's part of the original. So even though it's not a piece of the simplified rational expression, we do still need to think that, okay, x equals negative 2 is not in the domain. But what does that look like? Let's get our graphing calculator out just to see what that means to not be in the domain. So we're going to graph the original, x squared plus x minus 2 divided by x squared minus x minus 6. I can certainly see that vertical asymptote at 3. That's pretty clear. And I see the horizontal asymptote at 1. So I see both of those, the answers that we have written down. But what about that negative 2? It doesn't seem like anything is going on there. If I look at the table, at -2. There's certainly an error. So what does that mean? What happened? Well, if I do a quick sketch of this graph, what's really going on, okay, it looks something like this with our two asymptotes. At -2, there's actually just a little hole. There is an undefined value at -2. You can't see it on the graph because it approximates and gets so close to -2, it looks like it's filled in. Even if I zoomed in a whole bunch of times on -2, I probably still would not see that hole because of the way that the calculator rounds and approximates things. But this is a hole at -2. So we didn't have to mention that since we were only talking about the asymptotes, but if we had to talk about the domain, -2 would not be included in the domain. So we need to be careful about simplifying. We certainly need to do the simplifying, but we need to mention anything that we took out. Okay, last one. Find the domain, vertical asymptote, and horizontal asymptote. So I mentioned before, I always do the asymptotes first. If I need to find the domain, I'm going to do the vertical asymptote first for sure. So we'll come back to A. Letter B, we're setting the bottom equal to 0. And simplifying it, solving it. -5 divided by -4. So my vertical asymptote is the cubed root of 5/4, which is not a pretty number. That then is what our domain can't be. Our domain is everything except for that vertical asymptote value. See why doing the asymptote first is probably the way to go. It's just easy peasy. Once you have the vertical asymptote down, that's what your domain is. And the last step for the horizontal asymptote, where I'm comparing the power of the top to the power of the bottom, the degrees are the same. So for finding the horizontal asymptote, we divide the coefficients. So my horizontal asymptote is y equals -3/4. And down here is our homework, and that is section 6 from chapter 2 for pre-calculus.